In the previous two graphs, we asked what happens when budget sets are non-convex, while tastes satisfy all the usual properties, including convexity. We now reverse the question and ask what happens if budget sets are indeed still convex, but tastes are no longer convex. We begin by drawing three indifference curves that exhibit a clear non-convexity, but we continue to assume that more is better than less. To illustrate why we call such tastes non-convex, we can pick point A and B as illustrated and show the dashed line that connects A and B, which includes point C at its midpoint. We then shade in all those bundles that are at least as good for this consumer as bundles A and B. This would include a set that contains the middle indifference curve that contains bundles A and B, as well as all those bundles that lie above the indifference curve. Now notice that bundle C, as well as the entire line that connects A and B, does not lie within that set, even though A and B do lie within that set. Thus, the set that we've created, which is sometimes called the upper contour set, is a non-convex set. It is for this reason that we call tastes like this non-convex. And as we illustrated in a previous chapter, it simply means that averages are not better than extremes, at least in some cases. In panel B, we simply illustrate a linear budget constraint which gives rise to a convex choice set. Finally, we transfer the middle indifference curve from panel A, as well as the linear budget constraint from panel B to panel C, and we do it in such a way that the blue indifference curve is tangent to the magenta budget line at 2 points. To be more precise, the first of these tangencies is bundle A, and the second of them is bundle B. Now notice there was no particular reason it had to be that a single indifference curve that exhibits this non-convex shape is tangent at 2 points on that budget line. But it is a possibility to get such two tangencies as soon as we have a non-convexity in tastes. The conclusion we arrive at is the mirror image of the conclusion we arrived at in the previous graphs. There we showed that a non-convexity in budget sets results in the possibility of multiple possible optimal solutions for a consumer who has convex tastes. We now showed that when budget sets are convex, a consumer with non-convex tastes might also have multiple optimal solutions. Whether the non-convexity shows up in tastes or in budget sets, it is the non-convexity that gives rise to the possibility of multiple solutions. But if both budget sets and tastes are convex, we will not get such multiple optimal solutions. Most of the situations we will investigate in this text will be of this kind. In other words, in most cases, we will be able to assume that a consumer has a single optimal solution to the problem of doing the best he can given the circumstances he faces.